All right, we're rolling. So maybe just start by introducing yourselves, and then we'll get into the tough questions.
Okay, sounds good. Hey, I'm Steven Goderis. I'm a research professor at the Vrije Universiteit Brussel.
And I'm Vinciane Debaille. I'm a research director at Université Libre de Bruxelles, also in Brussels.
Thank you for joining me today. This is neither your first time in Antarctica, correct?
No, it's my 5th time.
And for me, it's the 6th time. Yeah.
Yeah, and what keeps bringing you guys back?
Well, we're mostly looking for meteorites. These are fragments from different planets and planetesimals and asteroids. And they could teach us a lot about our solar system, but also about our planet as a whole.
And the point is that in Antarctica, they're going to be concentrated by the movement of the ice. And so we find more meteorite than anywhere else in the world. It's not there is more meteorite falling in Antarctica, but because they're concentrated, by going to those places, we know we're going to find plenty of meteorites there.
So over the last few years, we've worked in the area around Princess Elizabeth in the surrounding mountains, both to the south and to the east. And now we want to take it to the next step, which is a mountain chain called the Belgica Mountians, which is about 350 kilometers away from here, to do the same things that we did here before.
So basically, we look where ice is actually moving upward, and in satellite images, this is looking blue. So we're looking for blue ice, literally speaking, on satellite images. And the good point is that we know those mountains have been visited in the past by our Japanese colleagues. So we know that we will be able to find many meteorites there.
What is also very interesting is that there's a tight connection between the ice and the meteorite. And we can use the meteorite to say something about the age of the ice, which means that we can deduce, based on the ages of the meteorites, how old the ice exactly is. And this means that we can make kind of maps of the surface ice, which tells us what is going on in these particular areas.
Very interesting.
We just keep going.
That's good. That's really great. It's just like bouncing off each other.
We've done this for 50 years
basically, finding meteorites is so it looks very simple, but we still don't understand exactly why and how we get this concentration. This is something we see, so we know it's happening, but we're still not sure why there's concentration of meteorites. So that's also why we study the ice. It's really to try to understand why we have this concentration of meteorites.
And is it ever possible to know how long a meteorite has been in that location, per se?
That's what we try to deduce. We use these very exotic components, nuclides, which are formed in the solar system when the meteoroid is traveling to space. It's being radiated and it forms particular nuclides. As soon as the meteorite arrives to the planet, starts a clock in which these decay away, and we can very precisely determine how long they have been residing at the Earth's surface.
Yeah. The only issue is that we need to do that in the lab. So basically, it's very cold in the field, it's very complicated, so we just bring the meteorite back to the lab, and this is where all the analysis will start only.
Okay, and what is like a typical age of a meteorite that you guys find?
So this ranges from anywhere as
today,
all the way back to several hundred thousands of years. So we know that there are some meteorites have reached the limit of even millions of years, but those are really the exception. If you find those old meteorites, it's also probably likely to find old ice, and this is where our colleagues from the FOA team have been really focusing on finding these old meteorites so they can also get to the oldest ice, and this is very useful in reconstructing the climate of the past.
Very cool.
So basically 90% of all meteorites are called ordinary chondrite, and ordinary means they're the most abundant. And of course, you know, this is a bit the Murphy's law adapted to meteorite. We're looking for very rare meteorites like Martian, lunar meteorite, or even meteorites that don't have any siblings right now on Earth. So this is, of course, we do not decide in advance, but this is really a hope.
There's always a chance that we find a meteorite that is the next piece of the puzzle that can help us to understand some very fundamental questions, like where does the water on our planet come from? Where do the organics come from? How did Earth evolve into this beautiful dynamic planet that we have today?
Very nice. What do you foresee being the biggest challenge while out in the field 350 kilometers away from the station?
The cold, I would say, first. Of course, Antarctica, this is summer, but this is still a very challenging environment for us. We need to drive long days. We need to do to take the best from our stay here. So we try to pushing a bit the limits for us, of course. But this is also very rewarding when you find a meteorite. So this is really cool.
So despite the fact that we have this really fantastic material, we're really well equipped. It is still very extreme. It's a very extreme environment, which means that any day, any time, things can go wrong in terms of electricity, in terms of the snow vehicles that we drive, and this is mostly the challenging aspect. So we're well prepared. We have good people in the field with us, but after all, I think that's still perhaps the most challenging part.
Yeah.
And maybe we go back to the meteorites really quick. What is the rarest kind of meteorite, or what would you be most excited to find in terms of the type of meteorite?
We do have some meteorites that have only one example right now in all the worldwide collection. So of course this is very nice to study, very challenging too. So who knows, maybe we'll find a very unique meteorite never found again already on Earth.
Yeah, I think you would probably say Martian. I would go for anything basically, any kind of thing that we don't have yet would be amazing. But as Vinciane explained already, we need a large number of meteorites before we find those really rare fragments. So it's a bit of a lottery, I would say, and depending on what we get, we will also do research on these particular fragments.
Yeah, this is a strange way to do science. Usually you have a question and you get the sample. But here we don't really decide what we will get, because this is just Mother Nature deciding for us. So we have several research projects, and we're going to select the one that we can do thanks to what we find on the field.
So the meteorites will stay in frozen form, so we will ship them back to Belgium in frozen state, where they will be defrosted under controlled conditions. After that, the meteorites become available to the entire scientific community. They are conserved at the Natural History Museum in Brussels. And through allocation requests, scientists can get fragments from these meteorites to answer some of the questions that we also have as a community.
So it's really a community, an open community where you're sharing. That's the beauty of the science community.
It's really treasure for the humanity, for sure. Yeah.
Not just the scientists. Yeah. Do you guys want to talk a little bit about the micrometeorites as well, or?
Yeah. So next to the meteorites, we're also looking for micrometeorites. Micrometeorites are fragments smaller than 2 millimeter. That's more or less what we can state. They're very tiny, but thanks to a lot of recent developments in terms of instrumentation, we now can also sample and characterize these particles. So despite they are very small, they also hold the potential to sample asteroids, comets that you cannot sample through ordinary meteorites, which means...
Yeah, so basically they are just dust. It's everywhere, but again in Antarctica they can be concentrated thanks to the wind, in cracks at the summit of mountains. So again we do have a natural concentration effect in Antarctica to find micrometeorites.
And there's no contamination, there is nothing here, so there is no welding materials, there are no railways, there is nothing, so it's very well preserved, very pristine, and these particles have the potential to really push the field forward as well.
Very cool. And is there a number where you guys, before you guys got in the field, or that you think, oh, it's a successful mission if we find X amount of meteorites, or is it really just...
Yeah, no, we don't get there.
Stay positive.
There are some people
bets.
making some bets going around, but in the end we'll get what we'll get.
Yeah.
And there's not much we can do to improve or to get a higher number.
Yeah.
Something that's funny to consider is that actually we're doing a space mission in Antarctica, because we're getting extraterrestrial sample on Earth. So of course we can fly to the moon, we can fly on asteroid, but actually in Antarctica you can also do a space mission.
And maybe it's much cheaper, and we sample many different bodies instead of just one.
Yeah, opposed to trying to go out to space, we should focus on preserving our planet.
We should do both, actually.
The more we can do, the better, for sure.
Yeah. I know it's a challenging environment to work in, but do you guys always look forward to coming back to Antarctica? Is it a treat, or is it What is your
Well, it's definitely-
relationship with being here?
I would say it's definitely challenging. Let's not forget we spend our Christmas here, our New Year as well,
Yeah.
and then some holidays. But on the other hand, it's been very rewarding by doing this kind of high-level research in an environment that not a lot of people get the chance to visit. I will be the first people going back as a research mission to the Belgica since the
60s, huh?
60s. So it's very promising, and we very much look forward to that for sure.
Yeah, and it's true that some days, you're getting cold, you're getting painful. It can be complicated, but and sometimes you wonder why you're here, why it's so complicated. But then when you come back, it's like it was a very amazing experience. So yeah, it's challenging, but at the same time there is a call for being here as well. It's a very humble experience and just wonderful at the same time.
Yeah, it keeps drawing you back. Yeah. And if you had one piece of advice for, let's say, a young aspiring scientist or a young person that would like to get involved in science, or specifically this field, what would that be?
I would say it's a challenging job for sure, but it's also very rewarding. So try to keep following your dreams.
Yeah, don't give up. Keep on going. It's definitely worth it.
Yeah.
Very cool. And then my final question: if if you had one big takeaway message or something you wanted to communicate to the public with regard to Antarctica per se, or just our planet as a whole, what would that be?
By studying Mars, some people would think that Mars could be a planet B, but I think this is really wrong. We just have one planet and we should take care of it.
I think I would like to add that we need fundamental science, blue sky science. It's really essential to make progress, and not everything needs to have immediate economic gain. It is in the long run that we as humanity make progress, and it sometimes needs something very abstract, like looking for meteorites or looking for space rocks on an isolated part of the planet to figure out where we come from and where we're going.
Very good, thank you. Is there anything else you guys like to add?
I think we did a pretty good job.
I think we're a good team.
I think you did.
I think we're a good
Really
team.
We've never done that together actually.